Okay, hello everyone, and now we continue with the viscosity modeling for gem model, which refers to viscosity calculation for oil and gas phase, so that we could apply to CO2 air well. The WinProp library and gem GD the methods we call geochemical and Pederson viscosity calculation or correlation in WinProp and gem. It is more difficult to match liquid viscosity data than gaseous data, so more regression may be needed for liquid phase. Viscosity matching GST is the recommended and default approach in GEM. It is normally less computationally demanding. Pederson method may undergo better regression for some type liquid, but that would of course affect more scenarios in which we are modeling in oil reservoir. For the case Pederson may be better reduction of petroleum liquid. For petroleum liquid, viscosity up to about 6 centipoise and will allow modeling variation of heavy oil viscosity with temperature and solvent concentration. Okay, we continue with the viscosity modeling for next slide. In this slide, I will introduce about GST correlation. The following read us the detail of the GST correlation. A report also in the GEM manual show the GST correlation. We can adjust parameter from A0 to A4. Okay, so this will be for our matching parameters together with the alpha exponent here. You see the alpha exponent here, okay? The alpha exponent used for critical volume in this correlation. The parameter mu star. The parameter mu star here, okay? In here, the low is the low pressure. If we discuss, it calculate internally. Why another correlation? Explained also in more detail in GEM manual under keyword viscosity. If you go to the GEM manual and you type in keyword viscosity, and you will see the following parameter here, okay? The GST coefficient value will be applicable for GST correlation in GEM. If the user wouldn't under it hit out or her out value, the value match value can be written out by WinProp. The PVT package one matching is performed against the laboratory data. So even though the equation calculation is too complicated, but by using the WinProp library in CMG, we can easily get the matching between the simulation and experimental data. So all of you guys don't worry about that. We can handle easily by using WinProp library in this simulation course. And now we go with the another correlation. We call that Pederson correlation. The Pederson correlation yield a different approach. It is based on the principle of the corresponding state to calculate the viscosity of a component or the mixture. Knowing the viscosity of a reference substance at the some condition of reduced pressure and temperature. So these are the parameters related to the reference. You can see the red circle I mark here, okay? The reference number knows the value viscosity for the reference fluid, which is the methane property of the methane worked out by using the WREOS. And Again, the user will have the possibility of matching data viscosity data by adjusting B1, B2, B3, B4, and B5. The information will be useful for you to get the history matching between the experimental and simulation. The default of the value already mentioned here. The user can define by yourself to get your matching between the PVT, experimental data, and simulation data easily. Okay, so that's all about the Pederson correlation. We will continue with the information about the CO2 density in next slide. Okay, here are some results regarding the carbon dioxide density. The log compare the reduction of the Ben-Robinson equation of state for CO2 viscosity at 3 different temperatures. The value from 20 to 40 degrees Celsius. Over the relative wide range of the rest value, the comparison here is between a reference equation state, which is the sperm, and the Werner equation of state developed in 1996, which were derived for the carbon dioxide basically for high temperature and high pressure conditions. So this shows indeed the divergence between the two equations at large value of pressure, but recently would match in more typical conditions of operation, and also the temperature. So this is to say that approximation, okay, is the approximation of using BR equation for CO2 seem to working well under the control or under operation interested. You can see the reference EOS and the BREOS. It shows a very reasonable matching between the two curves. Okay. So the similar consideration can be made regarding the reduced viscosity at different temperature and pressure conditions. Again, with the divergence from the reference equation of state. Again, to be seen at high pressure, especially with respect to the JST correlation. In this case, this shows also the reasonable match between the GST, Pederson, and reference EOS. So we can say that the BR and GST correlation is usually are reasonable for our simulation score. That's all about the viscosity modeling for SimGem and WinProp. We will meet again for WinProp property in next video.